Welcome to this AAI training video. In this video, we will walk through some common issues that you may encounter in your day-to-day activities. We will review how these issues come to your attention and the steps to troubleshoot and identify the underlying cause. Along the way, we will discover new features in the AAI web interface. In this first scenario, we are going to start with an alert informing us that a certain job stream is now forecasted to miss its SLA. Alerts can be viewed directly in AAI, sent via SNMP traps, or via email. In this scenario, we will look at the alert directly within AAI. Let's start off looking at the job stream in question. Reconcile Orders USA. If we click the job stream link, we see the basic information for the job stream by default. Let's go to the alerts page. We see that we have one critical alert showing us that the job stream is predicted to complete late. Let's go to the Run Details tab. You may need to use your zoom in and zoom out buttons as well as the slider bar to see this more clearly. The most important thing to point out right here is the now line and the current execution. The now line represents the current date and time. If you hover over the now line or flag at the top of the chart, you will see the exact date, time, and time zone. We also see the current execution. We can tell this is the current execution because the execution bar is bisecting the now line. Additionally, in the list of executions, this one has an actual start time. There is no clock next to it indicating that it is a forecasted start time. As we hover over the execution bar, we can see some run details. We can see the current status. It is running 70% late. When the job stream started and when it is forecasted to complete. We also see the SLA. Additionally, in the Run Details view, we see a small vertical purple line in relation to each execution bar. This indicates the deadline of the SLA we're trying to meet. Since the execution bar goes beyond the SLA line, we can clearly see that this job stream execution is forecasted to miss its SLA as the alert indicated. Now, let's start to dig into the details of this specific execution. We can do this by either clicking on the Start Time link in blue or by clicking on the execution bar. We now see additional details about what is going on with this specific execution. Immediately at the top of the screen, we can see the current status. The job stream is running, and the job stream is predicted to be late. We again see the now line in solid purple and then the SLA timeline in solid red. We also see the average end timeline in green. What we want to try and do is quickly zero in on what process specifically seems to be causing the problem, and then try to identify the reason why. The Gantt chart is a good way to visually look at the information, but the quickest way to identify which job is the problem is by looking at the tabular view. Beneath the Gantt chart is a list of all the jobs in the job stream, including various information. This is a small job stream with only 8 jobs. However, with larger job streams, you may need to use the filter button to narrow your results. You can select longer than average jobs on the critical path or both. We don't need to use this right now since our job stream is so small. A helpful column here is the deviation from average column. We can click the column header and it will sort the information in ascending or descending order. This allows us to see which job in the job stream is deviating from its average runtime the most. The first line reflects the container within which the target job is located. The second is a job, and here we can see that this job normally has an average duration of approximately 15 minutes. But today it is deviating from the average runtime by almost 1 hour and 45 minutes. Using AAI, we have quickly identified which job we need to look at in more detail. Let's look at the Gantt view again to see what else it can tell us. Each job is represented by a horizontal bar. The length of the bar represents how long the job has run or is predicted to run. Let's click on the Show Average Runs button on the toolbar. Now we see a second bar beneath our execution bar. This represents the average runtime of the job. This allows us to easily compare the average runtime and the current or predicted runtime. If you don't see the average runtime bar under every execution bar, you may need to go to the More Actions button on the toolbar, select Settings, and adjust what jobs the average duration is shown for. The second to last job, the same job that we identified as deviating from its average by a large margin, is displayed as far exceeding its average duration. We can easily see this because the execution bar on top extends much further out than the average runtime bar beneath does. Something else that is unusual is we see a blue triangle on the execution bar of the job in question. If we hover over the execution bar, we see the usual information such as current status, predicted start and end times, etc. But we also see a user predicted duration which is set for 2 hours. By default, AAI uses its own prediction model. But what has happened here is that a user has manually overridden that prediction. This can be done for several reasons. Generally, something unusual is going on and the operations team knows that this job will run longer than normal. This could be done because of an excessive number of orders that day or something similar. When this happens, AAI offers the capability to manually override the predicted duration. This can be very helpful because instead of reacting after the job has completed and it has already run longer than normal, we can leverage AAI to help us understand how this change will affect the process overall. We can see immediately if meeting the SLA will be a problem or if this increase in runtime for this job will cause further issues downstream. Although this situation doesn't happen often, it is important to recognize when it happens or how to override the predicted duration. Before we close out this scenario, let's point out a few other helpful things. When setting a new predicted duration, there is an option to enter in a short description. This can help explain why the override was put in place. To see this, we can go to the More Actions icon next to the job where the predicted duration has been overridden and select Edit Predicted Duration. Here we can see the description or explanation given was annual sale. We can also see when the prediction is set to expire. To set a new predicted duration, we go to that same More Actions icon and see an option for New Predicted Duration. In this case, since it has not been set on this job, all the values are empty. As we go back to the Gantt chart view, just a reminder that only some of our jobs are shown in red. Red folders or red execution bars indicate critical path jobs. And remember, since AAI is a dynamic forecasting tool, the critical path can change from execution to execution. Finally, although this is not necessarily instrumental in finding the root cause of the problem, another helpful tool that you can use in many scenarios is understanding how often this job stream misses its SLA. AI easily displays this. Let's go back to the job stream definition and the run details. Our time source is currently actual, but we can change this to relative to SLA. This now shows us every execution and a red SLA line. If the execution box is green and is before the SLA line, then that execution met the SLA. If the execution box is red and goes past the SLA line, then that execution missed the SLA. This is a very quick way to get a historical view of this job stream and how frequently it misses its SLA. You can even sort by duration, and all the missed SLA executions will come to the top. In this case, this job stream rarely, if ever, misses its SLA. Needing to override AAI's prediction model is not something that should happen frequently, but this scenario explains how to recognize when it has been done and shows that AAI does offer flexibility in the case of an unexpected situation. In this next scenario, we won't be responding to an actual real-time alert, but rather we've been called to do troubleshooting on a process that has missed its SLA multiple times over the past few weeks. We will look at the process and try to determine what has been happening. We will see if we can identify the root cause of the missed SLAs, or at least determine a solid path forward and the next troubleshooting steps. The process in question is our sales reporting process. From the job stream definitions area, we will click on the blue link for our specific process. This takes us to the Basic Information tab, and we can see our target job, active alert settings, etc. Let's go to the Run Details tab. As we look at the executions over the past 14 days, we can see some red boxes which indicate a missed SLA. Using the slider bar, we can go back over the past 14 days and see that we have multiple red boxes. So we've confirmed the report that this process is missing its SLA on a semi-regular basis. Let's use our time source relative to SLA. As we saw in the first scenario, this can give us a different view of the same information. This shows all the executions and which ones missed the SLA. However, let's also go ahead and sort by the margin column. Now we have all our missed SLAs grouped at the top. If we look at the other information displayed on the screen, we see the start and end times, and we notice that they display something interesting. All these executions that missed their SLA all started at the same time. 8 p.m. GMT. Before we dig into that further, let's look at another time source option to view our data. The SLA graph. This is the same information as the relative to SLA view, but just in graph format. Here, each execution's end time is represented by a dot. The red dotted line indicates the SLA. A blue dot below the red SLA line indicates an execution that completed before the SLA was reached. A red dot above the red SLA line indicates when the SLA was not met. If we hover over one of the red dots, we can see the start time, the SLA, 2 hours and 40 minutes, and the duration of this particular execution. For this first red dot, the oldest execution that didn't meet the SLA, we can see the start time is again from that 8 p.m. run we saw earlier, and that the duration of 2 hours and 54 minutes exceeds the SLA. The second red dot shows similar information as well as the others. Either time source view will lead you to the same place, the 8 p.m. execution, but each view shows the information slightly differently. Let's go back to our relative to SLA view and the original sorting by start time. We can see that this process runs every 4 hours. The midnight, 4 a.m., 8 a.m., noon, and 4 p.m. runs all meet the SLA, but that 8 p.m. run consistently misses it. Let's click one of the executions that missed its SLA just to delve a little deeper. As we look at the execution, we see multiple jobs ran longer than their average duration. This could indicate that it's an overall issue with this process, not just a single job or problem. Obviously, further investigation is needed here into what is going on at 8 p.m. that is causing this job stream to miss its SLA. However, by using AAI's features and leveraging all the data available, and sorting and viewing the data in different ways, we have quickly identified the cause of the issue. We can now dig deeper into that 8 p.m. time frame. Perhaps there were more sales orders being generated at that time and it's causing the process to run longer or something similar. In this third and final scenario, we're going to start out with an alert on a particular job stream. However, this isn't a real-time alert. Management has identified a process that appears to be missing its SLA periodically, so our job is to find out what is going on. For this scenario, we will show an example of an email alert and then we'll start troubleshooting. Here's our email. The email from address will be identified within your AAI configuration. In our training environment, this is set to be automation@broadcom.com, but yours will be different. The email identifies the severity of the alert as well as all the details about the alert, such as the target job, business area, alert date and time. There is also a link directly to the job stream in question. We can see that the last few alerts shown here indicate that the job stream exceeded the SLA. So let's start troubleshooting what is going on with this job stream. We can start off by going to the job stream definition area and selecting our job stream. In this case, we want the HR payroll job stream. We click the link which takes us to the Basic Information tab and then go to the Run Details tab. And we can see right away that yes, this job stream is missing its SLA. The red execution bars stand out. We can see both historical runs as well as predicted runs. Predicted runs by default are displayed at the top and will have a clock icon next to the start date and time or end date and time. We can see some green execution bars. These indicate the SLA was met or predicted to be met. 8 different executions the SLA was missed. On this screen, we see 2 to 3 days worth of executions. But let's go back further using the scroll bars. We see the job stream has met its SLA for multiple days. It appears to consistently meet the SLA for the most part, but as we go further back, we again see a grouping of red execution bars where the SLA was missed. We're starting to see a pattern. We can see the same thing in the relative to SLA time source view. Scrolling down as far back as 2 weeks ago, we can see the same pattern. It meets the SLA, misses it for a while, then starts meeting the SLA again. Let's go to one of the most recent executions that has missed its SLA. This is the 9 p.m. run. Let's click the execution bar to go directly to that run. We see the average end time execution bars displayed under the actual runtime execution bars. And specifically on the last job, the target job, the actual runtime far exceeds the average runtime. And this is what takes the job stream past the SLA. So this certainly seems to be the cause of the issue here. This was the 9 p.m. run. Let's look at the prior run. We go back to the job stream run details. Here is the 6 p.m. run. Again, that last job is running long. Let's take a look specifically at this job. We can do this by clicking on the blue link for the job name. The link takes us to the basic information of the job, and here we can see information such as what scheduler it is running on, the job type, etc. We can go to the Related Jobs and Job Streams tab, and here we can see the predecessor or successor information as well as what other job streams might be impacted by this one. This also identifies what business areas may be impacted as well. Let's go to the Average Runs tab. Here we can see the average runs in graph format. Each yellow line indicates an execution, and again we can see this pattern of the job stream runs fine for a certain number of executions but then misses its SLA for a while. Then it goes back to meeting the SLA. Let's look at the day of week stats. Here is some interesting data. This shows that the problem seems to be on Tuesdays. Every other day of the week, the job stream is predicted to run for an average of about 20 seconds. But on Tuesdays, it is predicted to run for an average of 30 minutes. So, we've isolated the job causing the issue, and we've also zeroed in on a particular day of the week that this issue occurs on. This should lead us to the actual underlying cause of the missed SLA. Additional troubleshooting will need to be done to determine what is happening on Tuesdays. Next steps might be to look at the machine that this job is running on to see if perhaps it is getting overloaded on Tuesdays and that is causing some kind of performance issue. This concludes our third scenario and our AAI training video. You should now be able to easily navigate through the AAI web interface, analyze data for both job streams and jobs, and go through some troubleshooting steps. While every scenario is different, these scenarios should have shown how powerful AAI is and how it can help you quickly identify potential issues on your system. You can find additional resources on the product page. Thank you.